Yes, it's on. Thank you for inviting me, representing CNAC. I will talk today about a publication we made, which is about the tectonic and architectural properties of biogenic materials. A little bit about me. I'm a Dutchman. I'm neither Swedish nor Danish, not Scandinavian. I was educated in the Netherlands. As you said, I work at CNAC at the School of Architecture in Copenhagen, and I'm also a practicing architect, also an experience that I hope to bring with me in the projects I work with at the architecture school. At CNAC, we focus on promoting the role of architecture in building in new ways and sustainable ways. We have a very big focus on biogenic and bio-based materials. And we both teach. We have a master program about settlements, ecology, and tectonics. And we work on a lot of different projects, collaborations, and this publication is also a result of one of those collaborations. It's part of the project that Stig Hesselund showed before. We call it we translate it as Roads to Bio-Based Building, because we thought it was a very broad effort, so which Stig called Pathways to Bio-Based Building. So there were a lot of different actors, as you could see in his presentation this morning, that are there, and we are part of the knowledge part. So there were different packages and different parts. We look at our publication, which you see here on the right, biogenic materials, tectonic and architectural qualities. We had three perspectives on this. So the first one was based on Scandinavian vernacular building culture, where we looked at buildings from open-air museums. And the second one is a mapping of biogenic materials in contemporary construction, mostly in the Nordics. And the last one is the part where I've been responsible, together with my colleague Nini Leiman, about constructional protection of biogenic materials. So the first one about Scandinavian vernacular building culture, we can pose that building biomaterials, bio-based materials are building culture. Those were the materials that were available here. And there's a lot of different regional traditions and developments that constitute of this building practice and building culture. We chose to focus on smaller projects, so not where big architects were involved, where there were big budgets, but especially buildings in a smaller scale, because those typically used locally available materials. So those were very interesting for us to study and to look at. And then we chose to, as I said, projects from open-air museums, because those are untouched, or they even reverted to how they were before. There was not added insulation, there was not used plastic paint, so they were a very good subject for us to study and most obvious to examine. So what we saw is that they were very much regionally influenced, depending on what was available on the landscape. How do you deal with differences in height is something very different in Norway than in Denmark, where it's very flat. What underground do we have? So we could see different foundation types. We could see a lot of different construction types. So based both on geography, available materials, and a lot of other parameters. What they have in common, in a way, is that they are very thrifty. They are very resourceful about how they use the materials that are there and that are available. And some common denominators we found are that they are sized according to the body. They're not very big. They should be handled a lot of times by people in one village. It was very much a collaborative project. Often, like in the US, you still have this barn raising, and like as an event and as a cultural thing. And then the second part is that it's differentiated according to materials and their structural purpose. Is also something Marva mentioned. It's fit for purpose, one could say. So materials were used very specifically according to how big they are and what function they had, so that you wouldn't use thick wood in a part that is not load-bearing, for example. So they really use materials fit for purpose. And then a lot of it was also designed to be disassembled again. And we could also see that in the projects, in the houses we studied. We could see that there's markings and carvings in beams that show that they have been used in other places before they were used in the examples that we studied. Then the construction techniques were simple. So there were simple methods, simple tools. Some we believe even date back to prehistoric techniques, but which have been refined continuously. So we can discuss whether and how complexity in modern construction can be reduced, and that also refers again a lot to maintenance, which we'll also come back to in our mapping of constructional protection. So to wind up is that in this part of the publication we look very much at these local materials and how the architecture was formed by the materials that were available locally, had a low degree of processing, and how they could be sourced in a very straight, very easy way, one could say, and also using a lot of side streams, which we also see today in contemporary biogenic and bio-based materials, that there's a lot of materials from side streams. So that means, for example, rest products from agricultural production, and new produced materials and recycled materials, such as those load-bearing constructions I just talked about. And then one of the things we found was the principle of the available nail, and that is kind of a red thread with all those materials that were being used, is that the available nail, the idea is that I need a nail and I have this nail. I perhaps don't have the perfect nail, but I have this available nail. I will use that. And you can see that across the board with different materials. A piece of wood is perhaps not straight, it's perhaps not perfect, but it's still fit for purpose, so we use that. And that was very interesting to see how that can be translated in contemporary building practice, and also in an industrial building practice, which is the field that we work with. The second part of our publication was a mapping of biogenic materials in contemporary construction, where we looked at different categories of cultivation. So agriculture, built on paludiculture, sea, heath, and forest, and then different categories of processing. So really from the raw materials to components to elements. And we looked at that for materials in Scandinavia, mostly in Denmark actually. Now that I'm in Sweden, I'll say Scandinavia, because there's a lot of the same materials. These are some excerpts from the publication. This shows flax, so it shows it first as the agricultural product in this case, and then it shows it as a raw material, in this case linseed oil, which is used in different ways in building industry, and other uses such as insulation here, and as linoleum, which is used for flooring and furniture design. We used that knowledge that we gathered in those others to develop a mapping of constructional protection of biogenic materials. And we understand constructional protection as where you use the building's geometry and shape and the material used to protect the biogenic materials that are used in there. And we made a taxonomy of risks, protective strategies, and methods. And the idea is not to promote that biogenic materials are bound with more risk than non-biogenic materials or non-bio-based materials, but it's a way of how they can be used in a smart way, and where we relearn from the past, which is almost sounds like the red thread today. So how we work with that, and in Denmark, there's this very strong sense of constructional protection. It's also part of the carpenter education. I don't know how it's here in Sweden, but it focuses very much around moisture. And also nowadays, in the newest versions of it, they say, okay, use impregnated wood if you don't want wood to rot. And we promote that one rather uses other measures to do that. And at the same time, we expanded the elements or the risk factors that you can actually deal with constructional protection. So it's also UV light, fire, dirt, physical damage, and pests. And we look at 3 strategies, and I will go on to some slides where it's a bit more close up because I think the images are very small, but we have 3 strategies where the most overarching strategy is also the most obvious one, is to keep harmful elements away from the biogenic materials so that they don't reach in the first place. But this is very difficult to achieve, but it's important we start there. And then the second one is handling harmful elements when they have reached the biogenic materials. So how do we deal with that? And then the last one, which has also not been part of the understanding of constructional protection in Denmark before, is to make sure that things can be inspected, that they can be maintained, and that they can be repaired. So also that there's this continuous lifespan of a building that is included in that. So this first strategy where to keep harmful elements away from biogenic materials, we defined 4 types of technical solutions. So the first one is relation to the terrain. So there's most very obvious ones of have a drop in the terrain, have a good base, or have something that is elevated above the terrain. And they're all very obvious, but it's just to collect all this knowledge and to try to relearn from it. And it's also not meant as something that we should go back in time in terms of architecture, of architectural expression, but it's about to learn from those very kind of common sense solutions. So then the second category is, how's it called? Udgravninger. What is it? Yeah. Overhangs. Yeah, thank you. Overhangs in buildings, and they can both be through roof overhangs, they can be in the building volume, they can be in a relief, in a facade. Then also vegetation is a way where nature can be part of actually protecting buildings through facade cladding, through planting around the buildings. And then there's to get rid of the water through gutters, through drains, and so on, to guide water rather than just to let it flow, to protect the biogenic materials. For each of the strategies, we found examples. We looked for examples. A lot of the examples that we found are not 100% biogenic. That's not where we are yet. So that is a premise we have accepted, that we can't find 100% or very few. And we also wanted to show projects in different scales, both in small scale and in larger scales, and different types of projects to open up for this. And also, we've also mostly chosen newer projects to show that it doesn't mean that we have to go back in time in terms of architecture or aesthetics, but that we have to go back in time in terms of our learning of how things were done before. This was a housing project in Switzerland where they use, in a way, an array of roof overhangs to protect the wooden facades. This is a smaller summer house in Zealand, north Copenhagen, which is raised above the ground, very simple, so protects also against water coming up from rain, against floodings and ground capillary effect from water coming up from the ground. So the second strategy that was handling harmful elements when they've reached the biogenic materials. There we talk very much about the orientation of materials and how they are cut off. Here we show, in a way, it could be a piece of wood, but it could also be attached roof that is cut off in an angle, so that because a lot of the biogenic materials have a capillary effect. So if you cut them off and apply them in the right way, then less moisture will be absorbed by wood. And sacrificial layers. Then the second method here is drying. So to have cavities, air cavities behind cladding to dry, and very important also to get moist air out from inside. And also very new one in terms of constructional protection is fire, so that you can actually use a building's design and material use to prevent fire spread without that you use active systems or that you use chemicals. And that's in a way also the overarching idea behind this study, is that you can protect a lot of these materials without using chemical substance or to use sprinkler systems or other active systems, but that you use passive systems. Here you see an example of that also with fire testing, where you have fire deflectors, which in this case are metal, so we call those enabler materials. So it's materials that can actually help to use more biogenic materials, so kind of accept those. We are also working on a research project where we try to use slate instead of metal. Here we found an example from the USA where they had a very decorative use of the air gap behind cladding. So there was also our intention of this project is that to find appealing examples also for architects and for clients, how one could deal with that. And then the third strategy, which was new for constructional protection, is maintenance, as we also have heard before, which is a very important aspect. And also from the idea that maintenance-free, as this modernist thing, is also often makes it impossible to maintain. So there we looked at a lot of different aspects. So it was disassembly, that you can actually find damages through, for example, visible installations, visible constructions. And the last one is access to materials and to constructions, both for repair but also for visible inspection. So there was a project from Material Cultures Practice Architecture, which is a half-timbered house with visible lime, hemp lime, where basically everything is revealed if there's water damages or other damages. And then this was a project from France where with a wood construction where you have wraparound balconies, which also actually are parts where there's not windows, but where you can still access the building and maintain the building. Yeah. So our idea is that this discussion about biogenic materials opens up new perspectives on how we can make new aesthetic experiences in architecture, and that they require deeper understanding of how we use them and apply them in buildings. Yeah. Thank you.